Hello everybody. So now we are resolving the problem based on the assumption of the boundary condition, or not the assumption, the boundary condition of no flux at the axis of symmetry. So what we will do is we will solve half the shape. So we will, I've already drew this half, which is identical to half this whole shape. And I will see if I consider the boundary condition on this side to be the no flux condition, or the other side. I can pick any of these halves. So I'm gonna repeat the boundary conditions that I have here, which is 0.1 for the top side and the bottom side. And for so I'm gonna repeat this so it's easier for us to see. So I'm gonna make it as 0.1. Just let me check if I have anything wrong. This is 0.1. This is 0.001. I'm sorry. And now the only difference, let me just make sure that I did everything correct. Okay, so the only difference is that I'm modeling from here. So this is where I'm gonna use the flux equation, or this shape of equation. So I want to put the flux equals to 0, so this is the flux, okay, the d multiplied by gradient of c, and this is q multiplied by c. This is part of the equation. Q is 0 and g is 0. So based on this, I have no flux at this edge. So this is how the boundary conditions are defined. It's the same for the three sides, and this is the flux side is 0. It's noticeable here that the shape or the color of the line depends on the type of boundary condition. So those for the constant boundary conditions have red color, but the blue one is the one that is the one for the for the flux condition. So I'm gonna refine the mesh, and now I will solve the problem. My expectation, if I'm doing it correctly, then this half or this shape would be identical to half of this shape that's here. So when we plot, this is what we get. So this is exactly what we get from here. The same shape of the flow. Everything is almost the same. If we wanna make sure that it's identical, we can we can draw the 3D plot. It's gonna be very meaningful. And taking a look at the 3D plot, you would see that this is exactly this, the same shape of the arrows, except for this side, of course, because there is no flux at this side, based on the givens that I have. But for the lines that I have, they are identical. The shape of the 3D plot is the same. Let's show the mesh and see how they look. So it's exactly the same shape. So this is one other option. If you wanna define the shape, or define the boundary conditions, they depend on the shape that you define, either to define the conditions based on the concentrations, or if you know a flux at specific surface, then this will make the shape different. But at the end, from your understanding of the system, it should be okay. You should get the same results from either this side or this side. This is gonna be helpful in a case. So let's take a look at the mesh. If we go to the mesh mode, the center line, let's say you want to get a concentration profile at the center line. The center line here doesn't have exact points on the nodes are not exactly on the center line. There are nodes that are to the right or to the left. So if you want to pick points that are exactly on the center line, that might be a little tricky. But here it's gonna be easy to pick the points. Even if you refine the mesh more and more, you still can pick the points from the outputs based on the inputs that you have, and or the output. I mean the outputs that you have from the simulation, because you can simply tell that I want all the points that have x equals 30. which is not gonna be accurate here. You can get points that are 30 point something, 29 point something, but it's not exactly 30 as in this case. It seems I have refined the mesh more than I should have done, and that's why it's generating an error, or it's taking long time. And this is a good thing to see, that and it's not recommended to do this like so much, because it's gonna make your computer tired. So this is all. There is only one thing that we have not covered in this toolbox, which is the unsteady state calculations. So this is going to be the topic of the next video, inshallah. So I'll see you then.